Welcome, everyone. We'll get started here in a moment. I think most people have joined us now, so thanks for joining me today. My name is Paul Gannett, and I'm the Principal Product Manager here at Onset. I've been here for 27 years, so you could call me the old timer here at Onset. I've helped develop most of the HOBO products that we're selling today. And I've had a chance to meet several of you over the years or talk with you virtually through the internet. So good to be meeting with you again. And today I have the pleasure of talking about our new MX800 series of loggers. We're very excited about these, and I'm looking forward to sharing information about them with you. So first, hopefully everybody's hearing me, but if you're not, send me a note. This webinar will run for about 50 minutes with 10 minutes after that for answering questions. Feel free to enter questions during the webinar if you like. Some of them I'll address as we go, especially if they're relevant to what I'm talking about at the time, and others I'll save for the end. But this webinar is being recorded and it will be posted on our distributor portal, so you can get access to it there. So here's a rundown of what I'm going to cover today. I'm going to start with just a brief overview of our introduction timing, so you have an idea of when things are happening. Then I'll give you an overview of the product line, its key features and benefits, talk about how to help customers pick the best system for their application, talk a little bit about applications, talk a little bit about positioning versus the competition, managing objections, and I'll have some time at the end for questions that I haven't covered during the webinar. So at this time, I think maybe I'll turn off my camera. You probably don't need to see that. I've seen enough of me. So let's get into the meat of the webinar. So first, the timing. Today, March 5th, or actually it's March 6th for some of you already, is our introduction date for this line of products. We're actually live on the web already. It's not on our homepage yet, but if you type in MX800 or MX801, you should be able to see the product pages on our website. And we will begin accepting orders tomorrow or today for some of you. I'll get my time zone straight here. And we're having a 6 to 8 week lead time right now. We're just still ramping up production, building up inventory so we can ship product, but we're not quite ready to ship yet. And because of that, large orders will require approval. We just don't want to commit to 20 units to somebody when we don't have that many units available. So any large orders, please check with us to make sure we can meet their timing needs. And I should say that this initial launch, we're just introducing the MX800 loggers, the CTD and CT sensors, and the cables for the direct read deployments. Later this month, we're going to be introducing the DO sensor and the 2-sensor adapter, which allows you to connect 2 sensors to 1 logger. And when those are introduced, they'll also have a 6 to 8 week lead time from when they're ordered. We have already started promoting these loggers and sensors. We've been doing some trade shows here in the US. And I have to say that we had a lot of international customers attending those trade shows. We did the Ocean Sciences conference. I was there earlier this month. And yeah, we had a lot from the Asia Pacific area in particular, I was noticing. And there was a lot of interest in these products. So I think you'll have some good interest from your customers in the MX800 loggers. In all this promotion, we've been saying the products are coming soon, and we've only had preliminary pricing to share with them. We actually just nailed down our pricing yesterday. So and I'll be sharing with that pricing with you today. We did announce that these are coming in our newsletter, and we've had some print and web ads. I think most of those, though, would be appearing here in the US and probably aren't showing up in your regions. We are doing a customer webinar. You're welcome to refer your customers to that. That's going to be on March 21st at 2 o'clock East Coast time in the US. So what are the loggers that we're introducing? Basically, there's two models of loggers, and there's three different types of sensors that can be connected to those. The first logger is the MX800. That's a submersible version where the sensors are connected directly to the logger, and that makes for the easiest mounting and deployment and being able to hide the logger out of sight. We also have the MX802 direct read logger, and that's for cabled configuration. So the logger sits above the surface with a sensor down in the water. And the advantage of that is that users can easily read out the data via the Bluetooth communications above the surface from the logger. You know, the wireless clearly does not go through the water, so they need to have that logger above the surface for that direct wireless readout. The sensors that we're initially introducing are the CTD sensor in 4 different ranges. That's for 4 different ranges of the depth, same water level ranges that we're offering now in our other loggers like the U20s. The other sensor is a conductivity salinity sensor, which also does temperature. And then the dissolved oxygen sensor is coming soon. That will also record temperature. All of these loggers are supported by HOBO Connect, our application that's supported on iOS, Android, and Windows devices. So a choice of platforms for our users to use and choose from, and then go back and forth. And they're all free downloads. So I think this slide is something that most of you are aware of. Is what is CTD? It stands for conductivity, temperature, and depth, and it's just a common way of referring to sensors that do this range of measurements. And conductivity, actually several different forms of conductivity. You can have electrical conductivity, which is the direct measurement of the conductivity. Specific conductivity, which is the conductivity adjusted to 25 degrees Celsius. That normalizes for temperature variations. Salinity, which is usually how our oceanographer friends think of conductivity or use conductivity. And we are also offering TDS, total dissolved solids, as an option. And users can pick and choose which of these measurements they want to log. All of these measurements are calculated in the logger, so there's no need for post-processing for the user to get those. Temperature is pretty straightforward, that is what it is. Depth really is a combination of measurements. First, we log the water pressure, which is the pressure of the water. You also need barometric pressure, which is included in the MX802 loggers. If you're using an 801, you'll need a separate logger. I'll talk more about that. That provides differential pressure, the difference between those two pressures, which can be used to get water level. So those are the measurements. The data I'm plotting here, you can see this is from a marina near here, which has a pretty significant tidal influence. You can see the purple line is the tides coming in and out. And you can also see that the temperatures and the salinity are correlated with that, the tides coming in and out, which makes sense. So first I want to talk about the loggers, a little bit of the key features of those and how those can benefit our users. One of the key features, of course, is the Bluetooth communications. These are part of our MX800 series of products, which all feature that Bluetooth communications, and it just makes for a very fast and easy wireless offload. And it's not subject to following and stuff. Doesn't really bother the communications because the Bluetooth will go right through that. Being part of the MX platform, it means that there's a common range of water parameters that can all be measured with the same software, the same ecosystem. It just makes it a lot easier for users to have a full range of measurements in one platform. The MX801 has the ability to detect whether it's in the water or not. It records that as an event every time it goes into the water, as well as events when it comes out of the water. This is useful for tidal applications or streams where occasionally the water level can go down so low that the logger is no longer in the water, and this is a way for the user to know that. The 802 logger, on the other hand, sits above the surface, so it does not have the water detect feature, but it does have a barometric pressure sensor, which is useful for things like calculating percent dissolved oxygen directly without having to do post-processing. So that saves users that post-processing step. We do have easy guided calibration for both the conductivity sensors and the DO sensors. I'll talk more about that during the presentation. It basically ensures good, accurate calibration. The loggers have user replaceable batteries. It's kind of like changing the batteries in a flashlight, so it makes it easy for users to get many years of use out of these loggers, and there's no need to have to send the loggers back to the factory for battery replacement, or worse yet, having to throw them out after the batteries run out. Especially for you folks that are remote, it's nice to know that your customers can just replace their batteries and they don't have to worry about sending them back to the States. We will offer the ability to connect 2 sensors to 1 logger. We'll be introducing that in conjunction with the DO sensor when we offer that. And of course, because the sensors are attachable, you can interchange sensors on the same logger. So just some other highlights of the features. I show a little picture there of how the batteries can be changed. It just means removing the end cap of the logger to change the batteries and slide them in. Capacity is roughly 730,000 measurements, and that's divided by the number of channels that the user decides to log. You know, I told you all the different measurements that can be recorded. They don't have to log all of those because that can use up the memory pretty fast if they're logging every single parameter. They can if they want, but they just have to be aware of the memory impact. HOBO Connect will tell them how long they can deploy based on the current number of channels they're logging and their logging rate. The battery life is 1 to 2 years, depending upon which sensors they have installed or attached to the logger. And the diameter, 1.63 inches. Sorry, I don't have that in metric. The operating range is -40 to 50 degrees Celsius. Because these are lithium batteries, it has that wide temperature operating range. So that's for the logger. The sensor, of course, is limited depending upon basically freezing. You don't want the sensors to get frozen. And the maximum logging rate on these is 5 seconds. I know our standard logging rate is 1 second, but just because of all the processing that's happening in these loggers, at this point, we're limiting the logging rate to no faster than 5 seconds. There is a magnetic fob, which is attached to the coupler that connects the sensor to the logger. That magnetic fob is used kind of like a push button. It's used for waking up the logger if it's been in the deep sleep mode, such as after it's been shipped. It can also be used for the pick-me, which is useful if you have several loggers in an area. You can touch the fob to the wake area, and it will raise that logger to the top of the list in the HOBO Connect software. That fob can also be used to start and stop logging if the user chooses that, either of those start and stop modes. There's a groove in the coupler that is used to store that fob when it's not being used to activate those functions. As I mentioned, the MX802 has a barometric pressure sensor in it. And this is a cutaway drawing of what that looks like. And the point I'm trying to make here is that the barometric pressure sensor is isolated in its own chamber so that the moisture only gets as far, any potential moisture that only gets as far as the barometric pressure sensor, and it protects the rest of the electronics from any moisture entering. There is a Gore-Tex, a membrane over the barometric pressure sensor to protect it from if it temporarily gets dunked in the water. There's no water that's going to get into the logger, so it provides temporary production. We do not recommend submerging these loggers. We rate them as IP67, and they are very weatherproof. The loggers do have a new logging mode, or it's actually just a variation on the multi-rate logging, which is to have the repeat and pause options. And that could be useful if users want to take a burst of readings, then kind of go to sleep for a little bit of time so it's not filling up memory with data that's not useful. Then they can wake up and take some more readings. One example is in wave applications. If they want to kind of get a sense for how high the waves are, you can do a burst of readings to get the kind of the wave height, and as well as use that to filter out waves if you want to just get the average water level. So you'd set that up as shown here on the screen with like a 5-second rate for a full minute, for a duration of a minute, and then the next interval can be a pause interval where it's not taking any readings for 5 minutes, and then the repeat option is on. That's the yes down here, so that it repeats that sequence until the memory is full. So now switching to talking about the sensors. The first two sensors we're introducing are the CTD and the CT sensors, which both measure conductivity and temperature, and the CTD also measures depth. They both use platinum 4-electrode conductivity sensors, which gives them a wide measurement range with good accuracy over that entire measurement range, plus or minus 2% of the measurement accuracy. The electrodes are centrally located within the sensor so that they're not right on the outside. And the advantage of that is that the electrodes are not affected by the well walls or anything else that the sensor may be up against. So that's important. The sensors are 1 inch in diameter, so they can fit down fairly small wells. Of course, that's limited by the logger if it's attached to the logger, or it can be on the cable, which is less than 1 inch in diameter. So you can get down the narrower wells using the MX802 with a cabled sensor. And we affordably price these. I'll talk about the pricing in a little bit. Some more details about the conductivity sensors. They should not be cleaned with any metal or plastic brush. We recommend the soft dental brushes like the one I've pictured here, which has kind of rubber tines on it that are very gentle on the electrodes, but good. They are able to take off a lot of the fouling. The water level sensor in here is in the end unit, very close to where you see the hole in the end there. It's the same durable ceramic sensors that we've been using in our U20 and HOBOnet water level sensors. So it's very well proven. And one of the things you'll notice is the end of the sensor is very flat. That's useful for using these sensors in applications where it can get very shallow. You put it so that it's pointing down, and it can measure water levels and it sit on the bottom and measure water levels down to 1/3 of an inch from the end. So that's better than any of our other water level loggers. The temperature sensor is also in this end unit, and that's important for good temperature compensation of the pressure and the electrode readings. And it also gives, just better temperature response, 3 minutes to 90% of the water temperature change, which is pretty good. It also reduces the amount of calibration solution that's needed for when you're calibrating the conductivity sensors. Speaking of calibration, this is the screen in HOBO Connect showing what the calibration process looks like. To do the calibration, use calibration solutions such as potassium chloride. That's what we recommend. That's kind of the standard for conductivity calibration, as it's the most stable. We recommend doing it in a lab, but users can do that in the field if they want, but it may not be as accurate. And to do that, they stick the probe, the sensor, into the appropriate calibration solution. In this example on my screen, they're using 15,000 microsiemens per centimeter calibration solution, which has a temperature coefficient of 1.91% per degree C. That's typical for potassium chloride calibration solutions. And when you press the start calibration, it starts taking specific conductance readings, and you can see it's not quite reached the 15,000 yet. This, once it's stable, it'll tell you that it's reached stability, and you can accept that as your first calibration point. You can do up to 8 calibration points. We recommend typically to do 2 calibration points, one at the low end of the measurement range and one at the high end of the user's measurement range. We won't have a field calibration. Users won't have to do that anymore, which they did have to do with our U24 loggers. They don't have to worry about that anymore. But it does mean there's no start and end point calibration, which was kind of a feature of those loggers. But in most cases, we find that our users would prefer to do their own adjustments for drift in the data. It's not always linear, so it's better for them to have control over that if they want. But they'll find in general that the calibration stability of these sensors is better than what we've offered in the past. The biggest issue is, of course, fouling. That will affect the measurements over time. So they do have to clean the sensors depending upon the amount of fouling in their environment. For the water level calculations, users, if they have the MX800 logger, which has the built-in barometric pressure sensor, they can get water level directly. So they don't need to use the water level assistant at all. The water level assistant is for users of the MX801 logger, which is the submersible logger. And because of that, it can't measure barometric pressure. So they need another logger, an MX802 logger that's deployed in the air or nearby to record barometric pressure, and that gets combined with the water pressure data to calculate water level. So to use the water level assistant, the user selects the appropriate water density, which in my case I selected brackish. They enter in the reference water level. I'm looking at the height of the water above the sensor, so I just entered 0. And then this is the barometric pressure file that I'm getting from a nearby 802 logger. So that gives you a sense for water level assistant. It's basically the same as the data assistance for doing water level calculations with our U20 loggers. So it should look pretty familiar. So now looking at the dissolved oxygen sensor, this is the same RDO technology that we've had in our U26 dissolved oxygen logger. It's proven to be very reliable over the years and maintains its calibration well. But this is a newer and improved version of that sensor. The big improvement is it's got a 2-year cap life instead of 6 months, and it maintains its calibration over the life of that, except for the effects of fouling. If there's fouling on there, that'll of course affect the measurement accuracy. So again, users will have to keep up with that. The caps will continue to work even after the cap has reached its 2-year life, and the user just needs to check the accuracy, and as long as the accuracy is still good enough for their application, they can continue to use that cap if they like. The accuracy is also improved over our U26 loggers. With calibration, users can get a plus or minus 0.1 milligrams per liter accuracy over the full range of 0 to 20 milligrams per liter, which is quite a bit better than the U26 logger, especially in the higher end of that logger's measurement range. It lost some accuracy. So better accuracy. So I got a nice durable PVC housing. And there's 2 calibration options for the dissolved oxygen sensor. One is a 100% calibration using the calibration booth that we're going to include with every sensor. That's very similar to the boot calibration that users could do today with our U26 loggers. They can also do what's called a concentration calibration, and that's where they stick the sensor into a bucket with a known concentration of dissolved oxygen. So they could have used a bucket of salt water from their site, for example, and use a meter to measure what that dissolved oxygen content of that is, and enter that in as their calibration reference point. So a couple of options. A couple other features. You can, once we introduce the dissolved oxygen sensor, users can combine that sensor with a salinity sensor with one logger, and that way the logger can record the salinity adjusted DO directly. There's no need for post-processing in that case. When used with the MX800 logger, which has the barometric pressure sensor, they can get DO % saturation directionally. Again, saving the need to do post-processing. And the diameter of the DO sensor is also 1 inch, same as the connectivity sensors. To attach the sensors to the loggers, you basically just plug the sensor into the logger. It plugs right in. It's got like 6 or 7 pins plus an alignment pin, and then you take this, what we call a collar or a coupler, and you clamp that around that connection. And it holds those two, the sensor to the logger, and then there's 2 screws that the user needs to tighten down to lock that collar in place. There's an Allen wrench that they need to use for those screws, and we include that Allen wrench and the coupler with the loggers. So users will have what they need. Use the same coupler to attach cables to the MX800 logger, which is our direct-to-read logger. And for connecting the sensors at the other end of the cable with the MX800, the connector coupler for that comes with the cables. So the cables will include that that coupler that locks around that connection. And the cable, the coupler, the sensor, they're all 1 inch in diameter. So it preserves the ability to get down those narrow wells. So I see a question on anti-fouling protection. I'll actually get to that in a couple of slides. It's one of the accessories that we offer, so I'll show you a picture of that. So thanks for asking about that. I'm actually getting into the section for helping customers configure their loggers and sensors. So just here's an overview of what the parts are and their pricing. The pricing here is all in US dollars. So the loggers are each 495 US dollars. The sensors, the CTD sensor is 895. So you combine the CTD sensor with the logger, that gets you a price of $13.90, which if you compare that to the other CTD loggers that are out there, that's that beats them all. It's a really good price. So I think you'll like that price point. The direct read logger, same price, with a sensor, but you need to add the cable, so that's going to be a little bit more when you add in the cable. The CTD sensor, connectivity and salinity sensor, that's $545. And the dissolved oxygen sensor, the pricing on this is still preliminary. We're expecting it to be in about the $900 price range. So again, that should be pretty affordable. The cables, for the standard lengths, the price of the cable is going to be $100 plus $6 per meter. So you can kind of calculate what they are. You have 7 standard lengths of cables. I list those down at the bottom, 1, 2, 5, 10, 15, 30, and 60 meters. And we also offer custom cables, but for the added handling costs, we charge an extra $20 premium for those custom lengths. For attaching 2 sensors to 1 logger, we're also going to be introducing a 2-to-1 sensor adapter. That's going to come out at the same time as the DO sensor. Oh, this is a good question. What is the maximum length for the cable? The maximum length for the cables is 120 meters. So, and that also relates to the maximum depth rating of the loggers. That rating is 100 meters. So 120 meters gives you enough cable to get down to the bottom and snake around a little bit if necessary. So, yeah, that should cover most applications that you're up against. So, talking about how to help customers figure out what to buy. The first question, which is pretty much the same for any conversation you have with customers looking at data loggers, is what do you need to measure? And at this point, we have just the 2 sensors to offer, the CTD sensor and then the connectivity sensor. And so those are the 2 choices. And in a few weeks, we'll also have the choice of the dissolved oxygen sensor. And then that opens up the option of getting 2 sensors, the dissolved oxygen sensor and the connectivity or CTD sensor. And that allows things like salinity adjusted DO directly. And the one question that came up earlier today was, can I combine 2 of the same types of sensors? In other words, can I have CTD sensors at 2 different depths? And you could do that. And you just, with the splitter, you have the cable run down to the first depth, have the splitter at that depth, and have a cable running down to the sensor at the lower depth. So you can do things like that. There's a lot of creativity in terms of how these can be configured. We'll probably come out with some sort of application note showing some examples and helping people configure cables and splitters and sensors. Now we have a request for a 300 meter. We're not quite able to do that at this point. So that might be an application where you need to use the submersible MX800 logger. Oh, and I see a question for a picture of the adapter. I'll show that in a couple slides. So coming up. So the biggest question I get actually is, which logger should I recommend? And each logger has its advantages. And the real question to ask is, how would they like to mount the loggers, and how would they like to retrieve the data? A lot of users want to mount on a stake or a buoy line or a cement block, like it's shown here in this the top picture. In that case, they'll want to choose the MX801 logger because that can be submerged. It can be out of sight, so nobody knows it's there. And especially if there's like boat traffic, that's a good option. The one thing to keep in mind, though, with the MX801 logger is that they'll need barometric pressure to compensate for barometric pressure changes if they're using the CTD sensor. They only need this if they're doing depth measurements. And there's a few different choices for logging barometric pressure. One is to use the nearby MX802 logger. They can use the barometric pressure data from that. If they don't have need for a sensor on that 802, there's a termination plug, the W plug, that should be added to that logger to make it weatherproof if there's no sensor attached. So that's something to keep in mind to make sure that your users that are using the 802 to log barometric pressure know that they have to buy that termination plug. They can also use data from an MX2001. That's kind of part of that same MX ecosystem. They can use the barometric pressure data from that if they have one of those already. And yeah, then the last point is just that they use HOBO Connect, the water level assistant, and I showed you that earlier, to combine that barometric pressure data to get water level. On the other hand, if they've got a well, or they can put in a stilling well on a dock, for example, they may find that the MX802 is the easiest choice because that allows them to get barometric pressure directly. The logger includes the barometric pressure, and that provides water level directly. You can just walk up to the logger, connect to it, and you can see what the current water level is with the MX802. The sensor stays in the water while the logger head sits above the water. So it's got to be someplace where the user can make sure that it doesn't get flooded. And but there's a lot of sites like on docks and stuff where they can do that. And it does require that they order a cable to connect from the sensor to the logger. So it gets a little trickier when they're looking at the two sensor configuration. So we had a question about this earlier. So on the top, you can see how the two sensor adapter can be used with the MX801, the submersible logger. In that case, you have the sensors right there. Just plug in the two sensors side by side. It'll come with a protective guard that goes over the sensors. And actually, this picture is a little bit misleading. If they want anti-fouling accessories, they would still attach those to the sensors directly. I'll talk about the anti-fouling accessories in a couple slides. If they're using an MX802, this is probably the most common configuration, which is to have the logger with a cable connecting to the splitter, the two sensor adapter, with the two sensors down next to each other at the where they're trying to monitor the water conditions. Oh, question about the diameter of the splitter. I think it's 2.5 inches, so it will just barely. It's a little bit smaller than 2.5 inches, so that it will fit down a 2.5-inch well. I also see a question in here about how far the Bluetooth communications can go. With line of sight, that'll go 100 feet. Pretty much the same as the other loggers. The Bluetooth 5.0 can go a little bit further in some cases, but we're still saying 100 feet. And we have some accessories, so be sure to ask your customers if they need any of these accessories. The first ones are the anti-fouling guards, which are $95 each. The housing, I'll show you a picture of that, that's $100. That W plug, if they're using the MX800 for logging barometric pressure, they'll need to add this plug to make it weatherproof. We're offering 4 different levels of conductivity solution for calibration. Users can, buy their own as well. Those are commonly available. And we do have we're still offering the sodium sulfite solution for the 0-point calibration for DO. And the same beakers that we've been selling with the pH logger for pH calibration, those will work for the conductivity calibration as well. So here's the anti-fouling guards. So for the conductivity sensor, it's this, it's basically a sheet of copper. It's got many holes punched in it, and it's wraps all the way around the conductivity sensor. It's held in place by 2 O-rings, which hold it securely in place. But it also makes it easy. You just slide off the O-ring and the copper guard for cleaning the sensor as needed. So it's easy to do that servicing as well. The anti-fouling guard for the DO sensor is actually the same one that we're already selling for the U26. So that's a screw-on guard, and yeah, real easy for the user to attach and remove as needed for cleaning the fouling. The one thing I wanted to note is the DO sensor. It has a guard that holds the cap on it, but it doesn't provide as much protection as the U26 guard. The membrane's actually exposed here, which makes it easier to clean, but it makes it a little less protected. So some users may want to buy this anti-fouling guard as a protective guard for the DO sensor. Even if they don't need the anti-fouling, it still provides some added protection. The another accessory that they may want to consider is a protective housing for putting their MX801 logger, and it's it's designed to be big enough to hold the logger and any of the sensors, including the DO sensor, and it includes a couple of grommets to hold the logger in place, as well as a grommet for holding the sensor in place within the housing. So it makes a nice, very robust housing for the logger for those underwater deployments. A question about the DO sensor cap. And I probably should have it listed on the accessories, is we will be selling replacement DO sensor caps. Because they now have a 2-year life, those DO sensor caps will be more expensive. I think the price on those is going to be, I can't remember, somewhere around $180, I think. Basically twice the price of the U26 cap, so 4 times the cap life for only 2 times the price. So it'll be pretty good value. But I'm going to make a note to remember to include that sensor cap. And moving on, the MX802 logger was designed so it could be mounted in the same well cap that we've been selling for the MX2001 loggers. So this attaches to the top of 2-inch wells. And this well cap is designed to hold the top of the logger high enough above the well, if it's like a metal well, so that you get good Bluetooth communications through that well cap to offload the data without having to even pull up the logger. No, yeah, somebody's trying to, a good question. I mentioned that we're going to be selling replacement DO sensor caps for the new DO sensor. The question is, can users use these new 2-year caps on U26 loggers to get 2 years of cap life out of them? And no, unfortunately, the caps are not compatible with the U26 loggers. So yeah, thanks for asking for clarification on that. It's a good question. As I mentioned, if somebody wants to use the MX800 to log barometric pressure, they're going to need to add the plug to the end of the logger to seal it off. So that's a picture of the plug there on the bottom. Or of course, if they're using the MX800 logger with a sensor attached to it on a cable, they can still use the barometric pressure data from that. Oh, here's another good question. Could somebody use the U20L for barometric pressure data? And it is possible. They'll be able to export the U20 data as a CSV file, and then they have to bring that CSV file into the water level data assistant. So it's not easy. I would recommend that it's easier to just get another logger, an MX800 logger, and use the data from that, or a 2001 logger. But they could bring in data from a U20 by doing that export-import sort of thing. So calibration solutions for the conductivity sensor. We're going to be selling the 4 different values. They're all $25 in US, and I mentioned the beakers. And I do recommend, for doing the calibration, you should have a pre-rinse beaker for rinsing it off before you put it in the final beaker for the calibration. And so for that reason, I recommend having 2 beakers for each calibration solution. So if you're doing calibration at 2 points, you should have 4 beakers to do the proper rinse and calibration. Let's see. Seeing a couple other questions. There's a question about using the well cap, needing an adapter for the MX800. No, no special adapter needed. It's the MX800. The mounting loop on the top of that is perfectly sized for compatibility with the well cap 1. So that makes it pretty handy. I'm not going to spend a lot of time on applications, partly because I don't have a lot of time. I'm seeing I've got 11 minutes, but here's some typical applications. And a lot of it's the same applications you've been selling our conductivity and DO loggers into already. Water quality, marine environments, coastal aquifers, compliance monitoring, such as acid mine runoff, wetlands mitigation. So now I just want to talk a little bit about product positioning versus our loggers, as well as our existing loggers, as well as the competition. So we don't have a CTD logger per se right now. So so this is the new MX800 here that I show for onset. And it's got the lowest price of any products out there. I'll show you the specifics on the next slide, but you can see it's lower price than the Solents, the in situ. Now it's possible that in some of your regions you have some local competitors that beat us on price, but just in that case, sell our loggers based on the performance. I think we really do offer the best performance price trade-off versus any of the loggers out there. So here's just a table. Sorry about the small type. This is a little bit of an eye test. So here's some of the leading competitors that we come up against: Solent, In Situ, Van Essen. I also included the U24 and U20L combination, just so you can see how that compares. So looking at in terms of price, our combined price for CTD is $1,390, which you can see is lower than all these other ones. It's slightly more than the combination of a U24 and a U20L, but it's a lot more convenient to use, and it's got several new features. It's basically the same as the Star Audi, which is more of a fish tag than a data logger. So it doesn't have the performance or the ease of offload that the MX800 has. CT prices, which is just that they need salinity and temperature. It's going to be around 1040. So that is a little bit more than our current U24 logger, but it's well worth it for the extra features like the Bluetooth communications, the built-in Bluetooth communications, the added accuracy. It's 2% of the reading, or 15 microsiemens per centimeter for the the low end of the range, whichever of these is greater is the accuracy. It includes the integrated barometric pressure sensor if you got the MX802, and of course the replaceable batteries. So in general, in selling against competition, you want to emphasize the ease of wireless data offload with a Bluetooth 5.0, the ability to get water level directly with the MX802, no post-processing required, the user replaceable price batteries, and a great price. Now looking at the DO loggers, when those come out, they have a little different positioning. They are not going to be the lowest cost DO loggers out there. PME has a very low priced DO logger compared to ours, but we're not that far away, and you get a lot of performance advantages. Let me jump into kind of the more details. So our price is going to be around $13.95, so you can see that is somewhat more than the PME logger. It depends upon the distributor. This is distributor prices I've given here, and so I went with the lowest distributor pricing that I found. So it may not be this competitive in your regions. Compared to the U26, I'm hoping to have it at the same price. That's my plan, but I got to get approval on that. But compared to the U26, it's got lots of advantages. The Bluetooth, the improved accuracy, the cap life. So we expect most new customers will go with the MX800. And if you compare it to the YSI Pro Swap, you can see it's got similar accuracy, but half the price of the Pro Swap. So pretty good value as well. And the replaceable batteries. So just in summary, for competing against the folks out there, if you know you're up against competition, focus on the ease of the wireless data download, the high accuracy, the ability to combine sensors on one logger and get things like salinity adjusted DO. And I guess I already said this, performance comparable to the YSI, but half the price. Now you might run up against some objections as you're selling these products to customers. And here's a couple that I've heard. You probably run up against others. So we'll work through those as we come across them. But some people have been a little nervous about the connection between the logger and the sensor and how that's going to hold up in their harsh environments. And our response to that is we actually have in the connector a stainless steel pin that goes between the two halves of the connection and makes it, so it doesn't flex and it doesn't rotate. That stainless steel pin really locks them together. And then that coupler I was showing you before, which screws together, makes for a very robust and reliable connection between the sensor and the logger. And if they're still concerned, of course, they can use our PVC protective housing, and they can fashion their own, for that matter, out of PVC pipe. Another thing that I've heard is that some of these competitors now do offer Bluetooth options, but the difference is these are adapters that get added onto the loggers. So they add to the cost, they add to, make them more cumbersome because they've got this extra piece they have to deal with. And the other thing about ours is it's Bluetooth 5.0, which means as long as you're within wireless range and the logger is logging, you'll be able to connect to it. You don't have to push a button, as is the case with several of these Bluetooth adapters that our competitors offer. So, yeah, the Bluetooth is our implementation of the Bluetooth is a real advantage. So, now I've got time. I got a few minutes left. I'll try to get to some of your other questions that you've sent in. So is it possible, so let me just read you some of these. And is it possible to use an MX800 without a cable and an external sensor as a BP logger? Yeah. Okay, that's exactly what I was talking about. Yep. Just to confirm, you can use the 802 logger as a barometric pressure logger without a cable and sensor attached, but you do want to use that plug that I talked about. Pros and cons of using the U26 versus the 801 with a DO sensor. So hopefully I've covered that question in that competitive positioning that I was talking about. Let's see. Okay. The question about sending the presentation. Yeah, we'll share that on our, and as well as resources on all of these products. We'll be sharing on our distributor portal recording of this webinar, and we can share slides on request. We don't share the whole presentation, but we can share slides on request. So let me know if you need those. Measure line pressure. A question about using the pressure sensor on pipes. If you can fit it within the pipe, it can measure the pressure within the pipe. It's not really designed for those kind of applications. So, but if you can fit it in, go for it. In some cases, people will use these within pipes to measure water flow. And these, I'm talking about big open channel pipes. In that case, that's where I'm more likely to see them. Yeah, there's a question about how to compensate for drift over 2 years when logging DO. To compensate for drift, the best thing to do is keep the sensor clean. But you can also recalibrate the DO sensor at any time. You could recalibrate it monthly. If you're seeing drift in the sensor, you can do a lab calibration or a field calibration of the DO sensor to tweak that accuracy back in there. A question about, does the cable have internal Kevlar strength members? And yes, the cable does have that internal strength member. So you can use that cable to suspend the sensor, and you don't have to worry about it stretching. It's a very durable cable that doesn't stretch. Will they have, I should have included this, what compliance approvals do they have? We have done the compliance testing on these, and right from the beginning, we have compliance in Australia and New Zealand. We're working with our distributor in Korea to get the compliance done there, but it's going to take some time to do that testing there, so it'll be a little bit of time. And at some point, we also hope to add compliance in Japan. I haven't started the testing on that yet, just due to some other things that are going on there, but we hope to get to that as well. All right. Well, I see we've hit our hour time, and I see that looks like we do have answered the questions that have been asked, so our timing's worked out pretty well. I want to say thank you for joining me for this session. Hopefully it's been informative. I wish you success selling these, and based on the reception we've had so far, I think you're going to have a lot of success with them. So thanks and good luck to you.